Good morning to all. Hope you are able to hear me.
Yes, ma'am.
Yeah, good morning. So we have completed 2 days of sessions. All right, we were working on text data, right? We were working on text data. How do you take a text data and how are we going to analyze? The first day we were seeing about the 4 different types of analytics. Can one of you say what are the 4 types of analytics that we were discussing on the first day? Day 1? Yes? Participants, please feel free to unmute your mics and speak. We were saying about 4 types of analytics. First is the descriptive analytics. If you take a data set, how are you going to describe it and how are you going to work on with that? And then day 2, we were working on what is that? Is my voice breaking? Just give me a second. You're able to hear me now?
Yes, ma'am.
Okay. Is my voice, if my voice is breaking, kindly let me know. Okay. So 2 days we have been seeing about different kinds of analytics, right? What are the 4 types of analytics we were discussing all about? Yes. I want the response from the audience, right? For analytics, first is descriptive analytics. How do you take a data set? How do you describe it? What are that you're going to understand from the data? And then we went into the diagnostic analytics. So is there anything that we need to curate it? And then we need to know about the predictive analytics. How are you going to predict if it is sales, if it is disease, or if it is, say, for example, some business or admissions or exam results or any kind that you want to do it, right? And then we were seeing about prospective analytics. Then we were seeing about prospective analytics. And then we started working on with the hands-on session. What are the different packages we have seen for the past 2 days? Can I have the answers on chat, please? What are the different types of packages in Python we have seen during the hands-on session? As participants, I strongly encourage you to put the answers. As pandas, matplotlib, then Seaborn for visualization.
Missing number.
Missing number for visualization. Even
missing number.
Yeah, missing number. Then yesterday we saw one package. Yeah, the correct is said, Richard sir. It's Plotly. You remember we're working with Plotly, and how are you going to do the visualization using?
Confusion matrix. We have the confusion matrix, bar graphs,
Yeah,
facet grid.
Yeah, those are functions. The package is scikit. sklearn. Okay, sklearn is the package. In that package, you remember we worked with train, test, split. You remember we were splitting the data set yesterday as training data set and testing data set. And then we're developing a machine learning model for it. And then what are the parameters we were finding out? What are the performance metrics? One is, the first metrics is accuracy. You remember? In some of the answers, and yeah, accuracy, how far it is accurate, and we saw the formulas: true positive plus true negative divided by true positive plus true negative plus false positive plus false negative. Then we were seeing about the how to we get a confusion matrix, and we try to analyze how the true positives and the true negatives work together, and what is true positive, and what you say, right, the diagonals, the number of predictions should be more than the opposite diagonals where it is false predictions. And then in classification report, what are the metrics we have seen? Can you tell me what are the metrics we have seen on the classification metrics? Yes.
And confusion matrix.
No, inside classification report, F1 score, a recall, precision. You remember the formulas that we were discussing? Precision, recall, and F1 score. All right.
Recall.
What was the data set we had on the hands-on session? What was the data set? You were trying to predict the disease of what data set we were working on with? Kidney data set. Thank you, ma'am. Yeah, Ramya, ma'am. Thank you. We were working with the kidney data set. And yesterday I had shared with you one more data set. You remember? What was the data set?
Recall
No,
F1
no.
report.
Yesterday I had
Report.
sent a data set. I had sent one data set on your Google Classroom that we have shared for this session. And also during the Zoom chat, I've shared it.
Diabetes data set.
Diabetes. Anybody work?
Yes, ma'am. Diabetes data set.
Is anybody worked with diabetes data set?
Yes, ma'am. I have done. I tried.
Who
I
are,
have tried, ma'am.
you can put your names on the chat so that we will know who and all have worked on the diabetes data set. What was your accuracies that you have got? Have you worked till accuracy? What is the accuracy that you got? Truly tell me how many of you tried it. If you have tried with the diabetes data set, type Y on the chat. If you have not tried the diabetes data set, type N on the chat. No. Others who have tried it, post it on, because it's an hands-on session. The more you try to put your hands onto it, you will be able to understand more. Otherwise, okay, try to work it out. See, the college has taken so much of efforts to bring in the faculties and to have a hands-on session with you, right? See, giving a theoretical part is pretty easier, but doing a hands-on session, it needs your complete cooperation. And also, I repeatedly was asking you, if you get doubts or anything like that, please feel free to share. Once you learn through you, so many students through your academic experience, they'll be able to learn through you. All right. Yes, I could see like Deepa ma'am has got. Okay. Have you posted it on the Google Classroom, the Python notebook? Deepa ma'am. Okay, so today we are going into the next concept called as image analytics. How are you going to take a data of an image and how are you going to find what are the content that is in an image? What are the images you can think that you can use it in healthcare analytics? Can you tell me? What are the images? See, we are focusing on healthcare analytics, right? We were seeing about a text data, what are the parameters, whether the disease is present or not. That is what we have been discussing all about. I want you to tell me what are the types of images that you could think that you can take it as input for image analytics.
Ma'am, MRI, CT.
Yes, MRI,
ECG,
CT,
and lung images,
lung images, X-rays,
X-rays, ECG,
ECG,
EEG,
EEG, PET scans, right?
PET test, spectre. Yes, ma'am.
Yes. So many things are there, right? So many things are there. So how are you going to take those data? How are you going to analyze it? Python is free of cost and it gives you plentiful packages, right? And it gives you plentiful packages how to use the image and how to take it out. Now, before I start today's session, I want to know how many of you are using your laptops or your PCs. If it is PC, type P on the chat. If it is laptops, type L on the chat. If it is mobile, we strongly don't recommend mobile. If it is mobile, type M on the chat. Using both, thank you, Deepa ma'am. Deepa ma'am, Suruchi ma'am, and Shanti ma'am are those we get. Yeah, PCs, thank you. Karthikeyan sir, Saranya ma'am. What about others? Only 3 responses out of 25. I wish everybody to give some answer. Is my voice audible? Sometimes you say my voice is not audible. Is my voice audible? Okay. I think it should be okay. Okay. So as you know, we are working with Colab is the tool that we are working with, and we are going to start with image analytics, right? What are the different for image analytics? What are the different packages are available? All right. Accordingly, we are going to work it out. All right. And now for this session, you're able to see my screen. Yes. Okay. So first, you're able to see my screen. Visible. Thank you, man. So, Manigan answer. So, first in image analytics, as we know, we have seen the different packages for Matplotlib, for Seaborn, all right, and Plotly, and you have got even more packages like Bokeh and so much and so more. All right. And today we are going to see how we are going to focus on the data set of type of image. Okay, image. So in image, I'm going to use this package called as SK image. Okay, and this I hope you are able to see in my screen. SK image is the package that we are going to use. Okay, inside that package itself, they are giving you, see, this is a package for image processing in Python. There are different packages, right? There are different packages, and this is one such package, Skykit image, right? For machine learning, you remember sklearn, which is called as Skykit learn for image processing, and this is the package, and this is available at free of cost. This is available at free of cost, and this is the package that we are going to use for the first we are going to use. So from that, I'm going to import datas and filters. Here itself, we are giving a lot of datas. Okay, when you go into the documentation, you can see what are the different datas they're trying to provide. Okay, different datas are provided by this Skykit image. So you can use, you need not download, you need not upload, you can keep using what are the data. See, can you see here sk image dot data? Can you see what are the different images? Okay, it's a brick wall, it's a camera is one image. Okay, data dot astronaut. Okay, cell, there's something called coins. Can you see here coins? Yes, one of you could unmute and say if you're able to see coins. Yes? Is my voice audible or not? You're able to see the word coin?
Yes, ma'am.
Okay,
It
okay,
is visible, ma'am.
okay. So I'm going to import the data, and it has got different filters. See, whenever you take an image, okay, the image is not going to be very clear. It will have something called noises, some salt pepper noises. You need to use filter to filter out what are the unnecessary noises. What are the unnecessary noises? So this sky image, okay, or you say it a Skykit image package, has got a plentiful filters. Okay, they've got different filters, Sobel filter, Gaussian filter, and I'm going to show you what are the different filters available. Can you see what are the different filters available? Okay, like Butterworth, correlate, okay, Gaussian filter, Laplacian filter, all right, median filter, Prewitt, okay, Prewitt filter, Prewitt filter, okay, Roberts, so many filters, Sobel filter. So from which I'm going to take, okay, in which I'm going to take filters, okay, from SK image, I'm importing data and filter. Okay, so matplotlib.pyplot as plt, okay, and in that I'm going to import two packages. The one is the data, the second is the filter. So image is equal to data.coins. So I've imported the data. So if I use data.coins, the image, the coins image will be loaded into here, into this variable called image. And plt.imshow, I'm importing plt like matplotlib. .imshow will be able to show me the image. Okay, listen carefully Now listen carefully. Whatever is the image that I'm going to take it and load it, but what is the data type of that image? It is a NumPy array. Okay. See, I see when I type image, can you see? This is how the images are stored. This is how the images are read in Python. But then when I want to show the image, I will be using image as the package. So I'm importing the first package, matplotlib, for visualization. Second, the SK image package, wherein I'm importing two packages. One is data, the second is filter. And in that data.coinsoft, there are different images that SkyKit provides. I showed you, right? Clock, coffee, different thing. Okay, if I want a coffee, okay, I can use it like data.coffee. Okay, if I'm going to use another image, maybe data.coffee. Can you see from this package COFFEE? All right, I can rename it as image underscore one, image underscore one. This is how because it is providing the data set, right? Once I imported the package, again it is NumPy array. Can you see? This is the image. So many images, SkyKit image packages is given. All right. So can you try this and try to import, and also you can go to SkyKit image and try to choose any other images that you would like to have, like a grass or golden eagle. So many things is there. Okay. Now everybody open the Colab and try importing one of the image from SkyKit and visualize it. Once you have done, put it onto the chat as done. Any doubts, you can ask me. Are you all trying? Yeah, Deepa ma'am has responded, trying. What about others? I want everybody to try. Yes, once you have tried it, post it as done. Yes. Any doubts also, you can ask me. And once you have done, try to take some other data. You can ask me. If you have completed, try to take some other datas from SK image, like I've taken data.coins, data.coffee, or cat, or Chelsea, so many things are there. You can take it out And anything new that you're working, also post it onto the chat, any new data. Done. Yeah, Deepa ma'am has done. What about others? Any others? Only I'm getting response. Others, can you give me a response, please? Okay, so this is how you take an image and then you load in the data. So what is the type of data inside? Okay, once I take an image and when I read it, what is the type of data? The type of data is numpy array, like which you can try for different images. Can you see here? What is the size of data? Okay, what is the size of the data, the rows and columns, right? So, and the shapes. Okay, this is the shape, like image, because it's a numpy array, it is represented as rows and columns. You have like image dot shape, image dot size. Can you try for the loaded image? What is the shape and size? Yes, as and when you're completing it, post it onto the chat that you've completed. Yes. And then now we are going into the filters. Okay, shape and size. How many of you tried? Kindly please do respond, right? So it will be easy for me whether you are on track. Only one response from Deepa ma'am I'm getting. Ramya ma'am, you got it? Yeah. Yes, I got response from Suruchi ma'am. Yes. Okay, so we have taken a data. Now there are different filters, I said. So filters are important for pre-processing. Filters are important for pre-processing. Some first I'm going to take a Sobel filter. So what Sobel filter it does, it finds an edge using edges of an image using Sobel filter to find edges. Say for example, your disease, you have got an image where you need to mark up the boundaries of the disease. Maybe it's a tumor or something or the other. Okay, for those kind of application, this filter is much used. So what is the data set that we have taken here? We have taken an image data set. So you remember saying this is the image data set. Okay, so that's about the coins. That's about the coins. So what I'm going to take, I'm going to take these coins data set. I'm going to give it to a filter call. I'm declaring another variable called edges. Okay, edges, which is equal to filters. Not, you remember I imported data and filters. I'm going to import filters, finding an edge using Sobel filter. So image is the variable that contains my coin, right? So plt dot im show edges comma cmap gray. So I'm converting my color of the image to be a grayscale image so that I will be able to clearly find out the edges of an image. Okay, so I'm using Sobel filter here. Likewise, you can try it out for different filters. Okay, say for example, if I'm going to take the same thing, you remember I took images one. Oh, image one, I had the coffee image, right? I had the coffee image. I can load image one. I think image underscore one I've given. What is the image underscore one? So, So I'm giving another image of the coffee. Can you see? It's not. First, you need to convert it to grayscale, and I'm using my CMAP. But more clear, the images, and you need to pre-process for this kind of data, right? That's, say, for example, if you've got like closed images, like only a few here are closed, only those edges could be seen. Okay. So here it's very clear onto your coins data set. MRI images, you will be able to do it very clearly. Let me see how many of you are trying it. Give the same image name what you have loaded. Are you all trying? Once you've completed, kindly let me know. We have loaded the image using SK image from the package coins, and we have got an image variable and using a Sobel filter, finding the edges and displaying it in grayscale. Yes, have you got it? Only 2 lines. Okay. Once you've tried that, then we move on to the next filter called as Laplacian filter. Can you see here Laplacian? Laplace filter. Finding the edges using Laplace operator, you know Laplacian, right? So using Laplace, here you're trying to see the image. Okay. Here we have given gray. Say for example, if I'm not going to give the C map, okay. So how does the image come? You're not able to see, right? So which is better? Sobel filter is better or Laplacian is better for this data set? For the coins data set, which is better? And the next, I would like you to try median filter. Okay, this is the next filter called median filter. It returns the local median of an image. Okay, it returns the local median of an image. So try Laplacian filter, Sobel filter. I hope you all should have tried. Now try median and Laplacian filter. Yeah, I'm getting response from Ramya ma'am. Try Laplacian filter. And median filter. This is Laplacian. And the next filter. Just keep changing these words alone. Once you have done, post it onto the chat. Done. Filters.sobel we have tried. See, this is sobel, and you have to send the parameter of the image that you have loaded, and then you're viewing the image, and this is for Laplacian. Okay, and then it is median filter. Try Laplacian first, and then we move on to median filter. A few of them are in the waiting rooms. Maybe the coordinators could permit them after checking their registration. Yes, hopefully done. Okay, Laplacian, and next the median filter. There's so many filters available, and as and when you get time, you can keep working on with the different types of filters. Are able to understand what filter does? Yes. Kindly give your responses on chat. And the next that you could try it is called Roberts filter. You can see in filter Roberts. Okay, find the edge magnitude using a Roberts cross operator, using Roberts cross operator methodology. Okay, as you could see here. Okay, we have seen what are the different filters: Sobel filter, Laplacian filter, then median filter, now Roberts filter. So out of all these four, which filter do you think for this particular image, edges are more clear? Yes, please. Yes, please. Can you give your answers on chat? Or you're connected? I'm not getting responses. Out of these four filters we have used, like Sobel, Laplacian, median, and Roberts filter. Out of all these four filters, for this, but see, for every image, different filters will look better. For this particular image, which image you think, which filter is better? Hello? Okay, can you tell me which filter is better? No responses, or you're not able to hear me? Sobel is better. Yes, for Sobel is better in comparison with all the four filters. Okay, in comparison with all the four filters. Kindly be actively participating in this session so that it will be interesting for you, for your median. Yeah, for each one of us, according to when you do research, like I've got like 8 to 9 scholars with me, and for each of them the same thing, but I teach for what is their application, what is the data set, and they do it right. And the next data set that we're going to take is data.astronauts. Okay, astronauts, like there are different images, but here you can see the type of the data. Okay, data.camera. All right. So 0 represents black on the pixel, 255 represents white on the pixel. Okay, 0 represents black and 255 represents white. And if I want to use masking of an image, okay, image is an numpy array. So I'm going to find image 2. So what is an image 2? I have this camera, right? I'm loading the camera onto me. I will give you time to work it out. First try to understand. Image 2 is equal to data.camera. Okay, I'm plotting it, and what is the type of data is a numpy array. So this is the numpy array of it. All right. So 0 means black when the pixel value, the matrix specifies the pixel value of the image. Okay, the numpy matrix or numpy array, it specifies the pixel value of the image. So I'm going to give another mask which is equal to image 2, wherein I've loaded the camera image greater than 200. Okay, I'm going to, if it is greater than 200, I'm going to mask it by 0. Now you are able to see the masked image. The image was like this before. After masking, can you see the difference? Yes, no? Yes? Are you able to get it? Okay.
Ma'am.
Yeah, now try to load that image. Now try to load this image. Image2 is equal to data.camera, and we'll move on into masking. Once you're done, put it onto the chat as done. I hope all of you are trying.
Done, ma'am.
Okay. Now we'll move on into masking. Can you try the masking? It's more than 200. You can increase. Okay. Okay. And then you're going to get this image. Let me know. All right. I hope everybody is trying. We have 31 people here. Are you all trying? Once you have tried, at least if you have done, put D on the chat. Or we have not come into CV2 at all. We have not come into CV2. It's Opencv. We'll be seeing Opencv maybe in the morning session or afternoon session.
Done.
I have not defined anything, Karthikeyan sir, as CV2 here. I'm not using Opencv. We are using, there are different packages. Here, the first package that we have taken is SkyKit image. Okay, you got it, right? So if I'm going to want to do the opposite way of it, okay, if I want to do the opposite way, I'm going to take values less than black to white and white to black. Okay, I'm going to mask less than 87. Okay, and I'm going to mask 255. See here, I mask 0. 0 represents black, right? Here I'm going to mask 255. Remember, I'm going to mask 255. So here, what is it white? It will be in black, and what is black? It is white. Able to find the difference? Yes, please. At least those are listening, you're able to find the difference. How far we are masking, it depends on this number. 0 represents black and 255 represents white. Here I'm asking 0. Mask value is 0. Whenever I have got the values greater than 200, I'm masking it to 0. Here, whenever I have values less than 87, I'm masking it to 255. Other than Deepa ma'am, let me get response from anyone. I'm always getting from one person. Anyone who's trying it out? Can you give me a response, please? Are you trying or able to understand the concepts at least? Yes, please. Okay. Once you have done, let me know. Yeah. Thank you, Suruchi ma'am. Karthikeyan sir, are trying it? If you're getting any errors or any doubts, please feel free to unmute and ask. Okay. We move on to the next. Okay. From the data set, I'm going to take Chelsea. It's a type of cat. And here you see the shape is a 3-dimensional. It's not always 2-dimensional. It can be 3-dimensional also. But when the coin, it was just 2-dimensional. But here the data set is 3-dimensional. Okay. So, and it comes with red, green and blue. Okay. RGB. Okay. RGB. Okay. Red, green and blue. And if it is 10 of comma 20, what is the array? And 50 of 60, what is the array? If I'm going to make it 0, okay, 0 to 55, 0, which means the red, green and blue, okay, and then I'm going to make it as a reddish cat. If I want to make it to be a reddish cat, okay, red, green and blue, okay, so I'm making it is greater than 160. So red is given as 255 and green and blue I'm making it 0. Can you see the color changes to red? Data is not defined. That's the error you get. Okay, Richard. So maybe initially you have joined the session. The first few lines you need to do it. Okay. You need to import these two packages. I'll put it onto the chat. Okay. These two packages, matplotlib for visualization, and then you need to import your data and filter, then only you'll get data. Okay, so you have got 3 channels: red channel, green channel and blue channel, RGB. You remember the color of the image that you get it as RGB. All right, and you can keep changing how whatever you want to mask and how do you want to make it. Okay, let's try the reddish cat, or you can make it as a greenish cat, or you can make it as a bluish cat. See here I've been given 255, 0 and 0. Okay, I don't know, today morning my internet gave me a kind of issue. Now what color you are going to see? Can you see you're seeing a green one? Okay, and the next thing, if I'm going to make it, I'm going to give it as hash, and I'm going to change the color to the last channel as 255. What color it will be? Can one of you say, please? Blue. Can you find the difference? Okay, can you find the difference? So for only one channel, I'm going to take values greater than 160, and that every column I'm changing. If you want to have red, have red. If you want to have blue channel, and green, have green channel. So try for all the 3, just copy it and you can try it out. Which channel you need to do it. Import the cat and keep doing it. If everybody could give me good responses, it will be good for me to understand. Are you all trying? I hope you're trying. First, you have to import the first two lines I've given on the chat, and then eventually you can try doing it. Yes, please.
Good morning, ma'am.
Yes, sir.
Hello, ma'am. Good morning.
Good morning.
Ma'am, 255 is asking, ma'am. Good morning, ma'am. Normally 0 to 256, 255 is okay, ma'am. But what is 160, ma'am?
I'm taking the values, sir.
That's...
It's a three-dimensional array, right? So it's a three-dimensional array. I'm taking the red, green,
okay,
blue.
Okay.
So for that one column, I'm going to take it more than 160. But one dimension alone. One dimension alone. So it's
okay,
not the entire thing. That the third dimension alone I'm taking, and that alone we are keeping to change the color. If I open my red channel, I get it red. If I get my green, you get it green, or if I open my blue, you get it blue.
Okay, ma'am. How you set 160, ma'am?
You can set any color.
160.
You can, if you make it 80, you can find. Okay. If you make it 80, you will find the difference. And you see, it's more. It's taking more of the color on the channel.
Blue is more. Okay.
Yeah. So
blue must be.
Yeah, blue.
Yeah, thank you, ma'am.
Okay. Because the values are between 0 to 255. To show the difference, we have taken the values higher to that.
Done, ma'am.
Done? Everybody done?
Yes, ma'am.
Okay, thank you. Anybody still trying? Okay. So you're able to understand how it works? The red channel, the green channel, and the blue channel. We are working on the package called as SK Image, SkyKit Image. Okay. And this already we have done for masking. We have done. Okay. Now we are going to take another image. This next package is called a SkyPy package. First package, what we have taken, SK Image is the package that we have taken, right? And now we are moving on to the next package called as next image processing package called as SkyPy. SCIPY. Okay, SkyPy image processing. Okay, remember first we took this package, SkyKit image package. There are still more to do on it, but I'm trying to throw away different lights. So if you're researchers or if you want to learn, you can keep exploring what you wish to learn about, right? And we have seen filtering techniques in SkyKit image. Okay, see here, SkyPy, it provides number of general image processing. Okay, it's not, some people think it's only Opencv. Yeah, Opencv is a huge package and we are going to work on with that. All right. But still, there are different packages. For some application, these packages are more prettier and more well suited than Opencv. It depends upon what problem you're trying to address it. Okay, for every lock there is only one key. All the key doesn't fit onto the lock, right? So for your particular research problem or for your particular problem definition, okay, what are the different? So here it's designed for arbitrary dimensions, like for morphology, for linear filtering, non-linear filtering, for the object measurements. Okay, in that we'll try to see one particular. So I'm going to use from SkyPy import MISC, and that is there you have got data, right? Here you have got something called MISC and n-dimensional image, right? N-dimensional image. So I'm going to import two functionalities from it. Okay, and I'm using like MISC dot face off, like data dot coins off, right? Here it is MISC dot face off. So face off is an image of a raccoon's image, right? So I'm going to import it. I'm going to show it to you. And then what is the shape of it? What is the size of it? What is the type of it? What is the shape? Okay, can you see this? It's an NumPy array. Okay, it's a three-dimensional one. All right, 768, 1024, and 3. And I'm printing my dimension. Can you see? This is the image. And here we are going to go on for a blurring of an image. Okay, blurring of an image. When you are using, even in your mobiles, you have got something called portrait where you are able to focus and then blur some backgrounds, right? So here, even for image processing in healthcare also, you can work on with. If you want to blur the image and focus on it, but this package is going to blur the image. Okay, we are going into the concepts of blurring. So from SkyPy, import the package MISC and n-dimensional array, and then keep doing it. Okay, any doubts? First, if you have done it, put quickly. I want everybody to work it on, put it onto the chat if it is done. I know you're all trying now. During which, if you have got any doubts, please do ask me. Others, you're all trying. Have you loaded and viewed the raccoon's image?
Doing, ma'am.
Yes, please. During which even others, if you have got doubts, also you can ask. There are so many people, but only few are responding. Don't hesitate. This is just a learning session.
Done, ma'am.
Once you have loaded that image, okay, now listen carefully. In SkyPy, we are going in for, okay, we are going in for blurring of the image. Remember in scikit-learn image, scikit, sorry, not scikit-learn, in scikit image, we were working on different filters, finding the edges. Here, we are going in for image. There are different things. You can do a feature extraction, okay, using SkyPy. All right, can you see there's something called Gaussian filter? Okay, I'm going to use those filters, all right, to blur an image, okay, to blur an image, okay, to blur an image. So for that, what I'm going to use, okay, I'm going to use, you remember I imported two things, right? One is an MISC where I got my data set loaded, and the second is ND array. So multi-dimensional array, okay, and I'm going to use a Gaussian filter. The face contains raccoon's face. Sigma, I'm giving 5. So when I give sigma 5, my value is like this, right? It's printing my blurred image. Okay, now listen. And the next variable I'm giving sigma as 10, very blurred. Can you see the difference between this and this image? Are able to find the difference? When the sigma value gets increases, the blurring is even more increased. Yes. Okay.
Yes, ma'am.
Yeah. So now try to do blurred image, n-dimensional image dot Gaussian filter. All right, with face sigma is 5 and sigma 10, you can even keep increasing it. But as you increase the values, the blurring is more. You keep trying this or trying it, or if you've got doubts, kindly unmute and ask. Only one response I'm getting, others. Ramya ma'am, you're getting it. Richard sir, Karthikeyan sir. Those who are using systems, can you please respond, please? Yeah? Done? Can we move on to the next? How many of you are trying? At least tell me that you're trying. Or how many of you are listening? If you're trying it out, type T on the chat. If you're listening it, type L on the chat. If you're trying, it means that you're putting a hands-on session, and you're listening means you're not trying, just you're sitting and listening to the stuff. L or T. Yeah, thank you. Okay, Rama Kalyani ma'am. Most of you are very silently working. Shanti ma'am, I've got first response from Rama Kalyani ma'am. What about others? Only 3 or 4 are responding out of 31. It's the final day of your session. The most challenging in webinars or online session is to get, see, I've conducted so many hands-on sessions, like 3 days. You can see on my website, it's be like 2 hours per day, right? And evening sessions like 5 to 7, and people have completed, and they have got a lot of hands-on sessions, right? And they keep responding it. But here, I think the level of response from the participants is quite low. Okay, but I want you all to try it out. Once if you try it out only, you will be able to understand how it has been working out. Okay, now we move on to the next package called. So how many packages we have completed? People are listening or trying. Can you tell me out of the chat what are the packages, image processing packages we've completed still now?
SkyPy, SK Image.
SK Image. Okay, SkyPy and SK Image. Can you all type it and put it onto the chat, the 2 packages that we have seen? I want everybody to put it onto the chat. SkyPy and SK Image. 2 packages we have completed. Kindly type it out and put it onto the chat. Okay. Not SkyPy. SCIPY is SkyPy and SK Image. At least when you type, you know what are the packages that we have seen till now. In SK Image, we were seeing about filtering functionality, and in SkyPy, we were discussing and we had a hands-on session on blurring an image. Now you know how to mount it, right? You can mount your Google Drive. Okay, and then now the next package that we're going to see is called as Pillow. Okay, the package is called as Pillow package. Okay, it's called as Pill. In here, I'm going to use image. I'm going to first package we imported data. You remember we imported data. Yes, and how is it, and filters. And the next image we imported MISC, miscellaneous, and ND image, where we use for blurring. And for this third package, we are going to take NumPy as NP. From pill, import image filters, and image enhancing. So I'm using image.open. See, each package is the way you open up your data is different. Okay, I have this image on my Google Drive. Okay, I'm opening my image. Okay, I'm displaying the image. Okay, and then we are formatting it. What is it? And then I'm enhancing it. Can you see the image is enhanced in comparison with this image? This is both contains the same image. Okay, both is the same image. Can you find this image is enhanced in comparison with this image? Yes or no? This image.
Yes, ma'am.
Okay, so here I'm going to use image enhance dot contrast dot enhance of 1.8. Okay, I can also increase the sharpness, I can increase the brightness, okay, I can increase the color, okay, so many things could be done. All right, can we all try one by one? If you're listening, at least make a note of it, after post which you can try it out. Okay, what are the different image enhancement techniques that pill provides? Is it's a factor, it returns the original copy. Okay, and you have image and its source, image enhance, image enhance dot contrast, image enhance dot brightness, image enhance dot sharpness. You can use any image that you have in your Google Drive. Okay, mount a Google Drive using this file. You can use this, or you can click this file. You remember first day I told you, right? Click the file icon, then you get the drive folder, click it on, and there also you can take up your path. Okay, so you get like this drive, and then you have to traverse where you have got image 11.png, and then you can show it. Okay, so here you can also mount it. Now let's everybody quickly mount it. I don't know where I have that image. Yeah. Can you see this is the image? If I'm going to download it, if anybody wants the same image, I can post it onto the uh, Zoom chat, or on the classroom. Okay, this is the image. Both contains the same image. Both are the same image, right? You can see the image. This is the image. Okay. I will share this image on the chat so that you can get it. Those are working. I'm sending it, the image, what I have used. You can load it onto your Google Drive and try the same image also. And you can try the same image also. Any doubts, kindly ask me. First mount the drive and then you can take the path and give it. Yes. Able to understand this concept? I will also post the image on the Google Classroom, maybe post it. If you want, you can use it. This is an example for image data set for pillow package. If you're in the classroom, I think 30 of you are there in the classroom. 33 have come. Those who are not into the classroom, kindly join it, where you've got the data set of kidney, status set, the heart, not the heart, the diabetes. This image, you can just click it on and join. Have you completed this? You need not type whatever is given in hash. The green one, those are comment lines. Try only the program. Try only the program. Yes? Once you're done, let me know, please. Hope you're able to display it. Okay. And then it says what mode, what is the type, what is the format, is PNG, the size of the image, and the mode, that is RGB. Try this. Kindly give me quick answers, right? So it will be easy for me. How many of you are really trying it? I know Deepa ma'am is trying. And one more ma'am, Rama Kalyani ma'am, and Raivati or Ramya or someone. Yeah. Have you loaded the image, or any image that you have in your Google Drive, you can load it. Any image that you have in your Google Drive also, you can load it. How many of you are at least making note of it? What's an error? We'll see to it. Okay. Make a note of the codings, right? If you're not trying it now, at least make a note of the coding. So this is this package, right? Pillow package. Image Python. Okay, pillow image processing with Python. Okay. So here they say call it as pill or pillow. Okay. What are the things that you can do to using pillow package? Okay. See, this is the pillows package of Python that allows you for image processing. Why it is called PIL? Python Imaging Library. PIL stands for Python Imaging Library. Okay, and have you display the image? What are the processing that you can do with histograms, resizing, rotation, filtering? Okay, and we are enhancing contrast enhancements. Whatever is the type of an image, the RGB, the type is ppm is an image, not image.open. You take any image, okay, you can open it and you can format it and you can show it. All right, and so many functionalities it provides. Okay, it provides, and I'm working on the image enhancement. What are the different filters available? How do you take it? How do you enhance it? All right, only a particular place is to be enhanced. Okay, what are the sequencing? You can cutting and pasting and merging. Okay, you can think of whatever that you would like to do it using pill. But what I have done here, I have loaded the image. I have loaded the image. Okay, and onto this variable using image.open of function. This function resides in this package. From the package I've imported this functionality, right? So image.open of, okay, this is the image, im.format, im.size, and im.mode. Make a note of it, im.format, im.size, and so first thing we are going to do is image enhancing. So im out is equal to image enhance of contrast of im. So im contains my image. Remember, im contains my image. Im is equal to image dot open of, okay, im contains the image. Okay, image enhance dot contrast. I'm enhancing to this. As and when I increase the value, the enhancement will be even more. Whenever you use mobile also, you see, right, brightness increasing, contrast increasing, right? Okay, if you take photographs also. So these things could be done using your Python package. Now try it out. Im dot image enhance. Im image enhance dot contrast of. We need to send the image and enhance of it like 1.8, and I am printing it, creating an object of the contrast, and I'm displaying it. If I increase some value like, see if I'm going to make it 2.8 instead of 1.8, can you see the contrast is even more increased on both, okay, in comparison with 1.8. You can think of developing your own Python web application, a web application using Python if you're interested in photography. Same thing we can apply it on our healthcare data sets. Healthcare data sets. Trying image.contrast. You're able to follow? If you're able to follow, type F on the chat. Those are listening to the talk right now. If you're able to follow what we have seen till now, type F on the chat, please. Yes, please. Let me see how many of you are responding or the ones who are listening to this. Yes, Rama Kalyani ma'am, Suruchi ma'am, Deepa ma'am. Only 3 out of 30. Only 3 of you are listening out of 30. What about others? If you're listening to this talk now, if you're able to understand it, you're able to follow. Yes, Karthik answer 1, 2, 3, 4. Only 4. Okay, now we go into same thing. You can copy and paste, create another variable like out1 image dot sharpness. Since if I'm going to give a value instead of 3, if I'm going to give 7, you can find it out how it is going to be. Same way as I've uploaded, can you see the sharpness is more here? It's more sharper. Okay, you can increase any values that you do. Okay, image dot sharpness of im dot whatever the factor that you want to value. Okay, image dot sharpens and image dot brightness. In this case, sensitive sharpness. First is contrast we have completed. Now we are doing a sharpness. Image dot sharpness. All right. Okay. Okay, once you've completed sharpness, go on for brightness. You can copy and paste, just change this variable and instead of sharpness, make it to be brightness and enhance factor, what factor that you would like to give. What factor that you'd like to give. Yes.
Done, ma'am.
Yeah.
Done everything, ma'am. Contrast, brightness, sharpness.
Enhance. Okay, you can try it out, enhance also. Okay, you can try it out, enhance. Okay, same thing.
Tried, ma'am.
Okay.
Tried, ma'am. Tried.
Okay, now we
Yes.
move on to the next package called as Opencv. Okay, now listen carefully. We are going into this package called as Opencv, or you call it as a computer, like Karthik and sir was asking in the starting. Why not Opencv? Why we have not he said why we have not imported Opencv or something like that. Okay, what are the packages we have completed from SK Image, right? Then we moved on into SkyPy. Then we moved on into
Enhancer.
Pill.
Image enhancer.
Yeah, Pill is the package which stands for Pillow, Python Imaging Library. Pill stands for Python Imaging Library.
Okay, ma'am.
Now we are moving on to the next package called as Opencv package. Okay, this is the Opencv package. Okay, so what it does, okay, CV it
Image
stands,
library.
yeah, CV it stands for computer vision. CV it stands for computer vision. This is the package Opencv. Okay, it has got lots and lots of see, it is released in December 2021. Okay, and every time, like if DB scan for super pixel algorithm, and what are the contribution it has been done, right? What are the contribution it has been done? Two people are there in the waiting room, maybe, yeah. The coordinators could check it out. Okay, and now I'm going to mount. I already have mounted, I need not mount. Okay, I'm going to use this one, OpenCV, matplotlib.pyplot. Okay, as PLT already have done. I'm importing CV2. How to import this package? For computer vision, it is CV2. And how do we want to read the package? See, for pill, it is dot open off. Right? For every package, how are you going to open up your package? How are you going to use it? It's totally different from each one. Okay, but when you take this, when you want to read an image, it is im read. Okay, cv2 dot im read. Then you have to give the path of it, and cv2 dot cvt color is the another function I'm going to use this in. Then I'll give you time to work on with that. Okay, and image one, and I'm going to convert my blue green red to red green blue. So wherever it is, this is my original image. Okay, this is my original image, right? So wherever it is blue, it will become red. Wherever it is red, it will become blue. This is my original image. I'm converting my BGR to RGB. Can you see? If you see my company's logo, CIRF, it's red. And this ISD logo is also red. But it's changed to blue and blue. And wherever it is blue, sorry, not this one. Wherever it is blue here, it is converted to red here. And it is light blue, it is converted into orange, and light blue to light orange. Even the face also has changed. The face color is also changed here. Okay, so I'm plotting this image. Okay, I'm plotting this image, and I'm showing it color to BGR to RGB. This is my original image. Okay, this is the original image. Okay, can you try any one of your image from your Google Drive, or you can upload it and try to convert your BGR to RGB. You're able to see my screen? Yes, you're able to see my screen?
Yes, ma'am.
Yeah.
I know.
Voice is breaking.
Yes.
Okay. Once I've done, kindly let me know. Take any image and convert it to be RGB to BGR. Yes, take any image that you have and you can convert that into BGR to RGB. I hope you're all trying. Once you have done it,
Done, ma'am.
you have done. Deepa ma'am, Suruchi ma'am done. Okay. Next we move on to the next one. So you have got your image from GBR to RGB, right? So wherever it is blue, it is the original image and it is converted. So if I want to convert my RGB image to a grayscale image, okay, before we process into it, we move on to the grayscale image. So CV2 dot, because we have imported CV2 dot CBT color image, color RGB to what we have given here, RGB to BGR, right? Or BGR to RGB. Okay, I'm reading it and it's an image one and I'm converting it into this. Right, image one contains my original data. This is my image data. This is my image data. So this is my image one. Okay, I'm converting into the grayscale BGR to gray. Try this, the grayscale image, BGR RGB to gray. Once you have done, let me know. Yeah, you have done. Thank you. Now what we are going to do, okay, what we are going to do, I'm going to you convert into another format called as HSP. But whatever you learn, you need to think how you're going to apply it for the problem formulation that you're going to work. Hue saturation value. Hue, HSP, it stands for hue saturation value. Okay, HSP. Okay, what is the hue? What is the saturation and what is the value given to it? Okay, how do you enhance it? Okay, HSV of an image. For some applications, the color space associated with this, right? Okay, and when you come into this, okay, hue saturation value, okay, BGR to hue, and then you're showing the image, and then you're showing this image. Okay, now we'll convert into hue saturation value. Afternoon, we'll go into canny edge deductions. Okay, you have done it. Okay, so okay, resizing is another. You remember we have uploaded the first in when we use SkyKit image. In image we have coins, you can use resize. Say for example, if you're going to take data sets of different sizes, before you feed into, you need to resize it and you go into a concept called interpolation. Okay, interpolation, cv2.inter area. First I will show to you and then you can run. So smaller images, okay, 250, 100. And then the interlinear is another kind of interpolation, okay, and then internearest, okay, and intercubic, and these are the different kinds of okay, half of the image, bigger size of the image, stretching this image. All right, we are going to do a stretch near image, and then original, half, bigger, and interpolate. So this is the interpolation. There are different interpolation. I'm using a for loop because I've got 4 images. I in range of count. What is the count value is 4 because I'm going to display using PLT. I'm using subplots. The first one shows how many rows. I'm going to have 2 rows, and each row how many columns. I'm going to have 2 columns. That is what here I'm giving 2, 2. And after the first 2 images are given, I'm incrementing the row by 1, I plus 1, the next 2 and 2. All right, and then I'm printing the titles of this image where I have here, and I'm showing the image where I have in this list. So if you have got so many images, you can have it as a list. From the list, you can pull it out and show the images. Okay, different kinds of interpolation. How do you resize and do the interpolation? Okay, can you try this now? Maybe I can think this image. Can you see the bigger one? 0 to 1500 and 0 to 150, the stretch.
Yes, ma'am.
Okay, so you can resize it.
Yes,
Say for
ma'am.
example, if you're going to use for healthcare analytics, different data sets of different size, you need to resize it. That's the first step before we go in for a machine learning or deep learning algorithms. Try to take any image and then do resizing, bigger size, stretch and interpolation. Yes, I hope you're all trying it. So 4 functionalities. Once you have done, you can tell me that you have done. Yes, ma'am. Any doubts, Shanti ma'am? I hope you're all trying. Yes.
Done, ma'am.
Done. Okay.
Finally.
Finally. Okay. I think you are the one who are doing
It
it.
took too long time, no, ma'am. So only.
Okay. So what are the things that we have seen from morning till now? The different image processing packages. Other than DeepMM, can one of you tell what are the packages that we have got introduced using image processing? Let me see who's going to answer. Anybody? What are the packages we have seen? Okay, anyone can answer? What are the packages in image processing in using Python that we have seen? Yeah, some of you are giving the answers on chat. Yeah.
Skype image, SK image, PIL, Opencv.
So we have started with SK image, which stands for SkyCut image. Okay, so what is the functionality that we tried using SkyCut image? In first package, what is the functionality we have seen in SkyCut image? You remember we worked on filtering mechanism. What are the filters that we have seen?
Black and white filter mechanism. That zeros and 255.
No. The Sobel filter, the Laplacian filter, the median filter, and the Roberts
median
filter.
So Sobel filter.
Yeah, 4 filters. Yeah, thank you, Karthikeyan sir. You said you have seen 4 filters.
Laplace.
Sobel,
Median.
Laplacian, median filter, and Roberts filter. Median. Out of which Sobel filter is good. Okay. So there are many functionalities that you can do it in SkyCut image, but what predominantly we have seen today is image filtering, okay, which removes your noises before you start developing your algorithms. The second package that we have taken is SkyPy. Okay. SkyPy, SCIPY. In SkyPy image, what is that? What is the functionality that we tried in SkyPy image?
Ma'am, resize the blurred image.
Yeah,
blurring
of an image using Gaussian filter. You remember? ND image dot Gaussian filter. So we took an image of we took an image of raccoon's face. Okay. Then once the sigma values is getting increased, okay, when the sigma value is increasing, then the blurring value keeps increasing. Blurred image and very blurred image. That is what we tried out in SkyPy image. What is the third package that we have seen? PIL, which stands for Python Imaging Library. Okay, which stands for Python Imaging Library. In Python Imaging Library, what did we see? We call it as
we have seen the image
enhancement, contrast, brightness, sharpness. Okay, enhancing, right? Image enhancing dot contrast dot brightness dot sharpness and enhancing. So how one image, how we are able to enhance it, right? The sharpness, the brightness, the contrast, right? There are different functionalities that you can use in PIL, but for today's session we have seen one such functionality of using a package. And when you want to read, for the first package is IM read, okay, and for this it is image.openOff, okay. And again, the last package that we have seen is called Opencv. Okay, Opencv. And in Opencv, what we have seen, we are changing the color channels from blue, green, red to red, green, blue. Then what we have seen? Then we've converted into grayscale. Yes.
RGB to gray.
Yeah, and then we were going into HSV. What HSV stands for?
Resize.
Yeah, HSV is hue saturation value. Remember?
Interpolation.
HSV, we tried using HSV.
Yes, HSV.
After we completed resizing, making the image bigger, then we went into interpolation. Then we went into interpolation. Yeah, then we went into interpolation. So these are some concepts that we have seen using image processing. Afternoon, we'll try to take an image, all right, and from that image, how are you going to see to it? Okay, from that image, we'll see how are you going to find an edges. Okay, how are you going to find? We need to move on into translations, augmentations, right? These are the concepts that we'll be seeing, and thresholding of the image. Okay, and then finding the edges of it. Okay, so these things we will be seeing it onto a afternoon session. All right, any doubts that we have seen in the forenoon session, different packages? Because we need to go into the healthcare analytics, but before which I wish to know, introduce the different packages available, then it will be easy for you to work it on with. Okay, you have to, it's your innovation and your creativity of your mind to put onto the data center. Okay, and how it works. So this session would have been useful to you. Any doubts you have?
No doubts, ma'am. Thank you for the wonderful session, ma'am.
Thank you. Okay, any questions you can ask? We have 1 minute before we close. And only one thing I would like to encourage all the participants to get yourself involved. It's not listening session, it's hands-on session. So once you put your hands on and practice it, everybody, then it will be more useful for you. All right, thank you. Over to the organizers.
Thank you, ma'am, for your valuable insights. I request all the participants to join sharply at 1 p.m. for the next session. Now, the participants can leave the meet. The feedback link is shared in the chat box. After completing the feedback procedure, the participants can leave the meet. Thank you, ma'am, and thank you all.